Hello and welcome to Unit 3, Section 1, Solving Quadratics by Graphing. So in the last unit we talked a lot about quadratic functions. We talked about the different types of forms that we can express a quadratic function in. And one of those forms that we talked about was in standard form, and you see that here. So what we have here is a quadratic function that is expressed in standard form. Okay, so this quadratic function is written as y equals ax squared plus bx plus c. And of course, the x squared term gives us our quadratic term, the bx term is our linear term, and then our c is our constant. And a cannot be 0, because remember, if a is 0, then this quadratic term goes away, and we're left with bx plus c, and we're just left with a linear equation. Okay, so just like we can have a quadratic function, we can also have a quadratic equation. And it is an equation that is of the same form. Remember, if we have vertex or intercept form, we can write it into standard form. And we take that standard form and set it equal to 0, again, where a is not 0, so that is still a quadratic. We say that that equations like this have a degree of 2 since the greatest exponent of the variable is 2. Now, notice that the quadratic equation only has one variable and all the exponents are positive. So when we're only looking at one variable, we can solve for that variable fairly easily. But here's the problem, is that we have an x squared term, and we're going to have to deal with that x squared term somehow, okay? That x squared term is also going to dictate how many solutions we have as well. So we're going to be getting into the different ways in this unit that we can solve a quadratic equation, and the first of which is solving it by graphing. So this is what we're going to look at here in this section, is by solving by graphing. Well, we're going to have solutions, and let's start off by talking about what those solutions look like. The values of the variable that satisfy that equation that you saw up there, that ax squared plus bx plus c equals 0, well, those solutions are called different things, and it's good for you to know all the different possibilities of what they can be called. They can be called roots or solutions, okay? So solutions is kind of your general term for anything that we're looking for the answer to, but it can also be called roots. Now, there are three possible outcomes when solving a quadratic equation. The equation will have either two real solutions, one real solution, or no real solutions. And here I've provided a graph of what all three of those look like. So in the first graph we have two real solutions, in the second we have one, and then the third one we don't have any. Well, what do you notice about what those solutions are? Well, in this first graph we have two solutions, and we happen to have two x-intercepts. In the second graph, we have one solution, and, well, we have one x-intercept. And then where we have no real solutions, we have no x-intercepts. Because the solutions occur where the parabola crosses or touches the x-axis, solutions are also called zeros, because your y value on the x-axis is 0, and they are simply your x-intercepts. So you remember back to the last unit where we had x-intercepts as something that we could identify on a graph of a quadratic, and we used the x-intercepts in intercept form. Well, here it turns out that those intercepts happen to be our solutions. All right, so let's move on down a little bit and talk about solving by graphing, okay? Now that we've got some of the terminology under our belt. Well, we've already kind of touched a little bit on what that looks like. Okay, so what that's going to look like is you just simply take your quadratic function, your quadratic equation, and you're going to graph it. And after you graph it, we're going to look at what the x-intercepts are. And if we can determine what those x-intercepts are, then we have our solutions. Okay? Now here at the bottom, I gave you a little bit of content that we've already previously covered, but I wanted to give it to you in one place so that it's clear. We have three tables here. This first table is your parent function. You saw that at the very beginning of Unit 2. You have x here where we just pick values, 0, 1, 2, 3, 4, and then your parent function is x squared. So if y equals x squared, if x is 0, y is 0. X is 1, y is 1. X is 2, well, 2 squared is 4. If x is 3, 3 squared is 9. If 4, then 4 squared is 16. Well, this is a little bit of a shortcut in figuring out what your a value is, because remember, two big things that we needed to be able to graph was our vertex and our a value. Okay, you can find the vertex by finding your x's as symmetry and then plugging it in to find what your y is, and that gives you your vertex. But to find your a, you can look at the graph and determine it, and you can look at your equation and determine it as well. So looking at the a value of your equation is always that leading term, no matter what form you have. That includes standard form. If it is compressed by, say, a factor of 1/2, then you're going to take that bottom number in your fraction, and you're going to multiply x by that number. Okay, so all of these values for x become twice what they were. Same thing goes for your y values. All your y values will also double. And then you can graph your points off of your vertex from this, okay? So your vertex would be that 0, 0 kind of starting point. And then from your vertex, you would go over 2, up 2, provided your a is positive. From your vertex, you would go again and go over 4, and then up 8, and then over 6, up 18, if your graph is large enough to provide for that. And then you can sketch your graph from there. Of course, all these y values become negative if your a is negative, okay? So instead of going over 2, up 2, you would go over 2, down 2. Now, if it's stretched, you leave your x alone. Say if it's stretched by a factor of 3. If 3 is your a, then you're just going to multiply all your y's by 3. You leave your x alone, you multiply your y's by 3, and everything else is just the same. So you take your vertex, and for the first point, you would go over 1, up 3. Then from your vertex again, over 2, up 12. Okay, so that's just a little refresher on how you can sketch a graph, provided you know the vertex and you know what your a value is. All right, so let's do a couple of examples here to kind of talk about how we're going to find what our solutions are. So for this first one, we are given x squared minus 6x plus 5 equals 0. Well, this is standard form, and the first thing we want to find is our axis of symmetry. Well, we can do that by using negative b over 2a. And our b in this one is negative 6. Our a is 1. And so we end up getting 6 over 2, which happens to be 3. All right, we've got our x value. Now to find the y value of our vertex, we're going to plug 3 back in. So we're going to have 3 squared minus 6 times 3 plus 5. And that gives us 9 minus 18 plus 5. So our y value ends up being negative 4. And so our vertex is at the point 3, negative 4. And now let's look at what our compression or stretch is. Well, we want to know what our a value is. So what's our a value? Well, we look at what our a value is in front of this x squared. There's nothing in front of it, so it's understood 1, and that's our a, which means we're going to be concave up, and it's going to be a standard parabola. There will be no stretch, and there will be no compression. So we start with our point 3, 4, or 3, negative 4, I should say. And we're going to plot our vertex there. And then we're just going to plot a point here and here. And then we go over 2, up 4. And then over 3, up 9. And you can draw your parabola through that. Now, I'm not going to draw my parabola. You can sketch it for yourself. You can do it much better than I can here. But what we're really interested in is where the parabola crosses the x-axis. And you have that here and here. Okay? In fact, I will go ahead and sketch the parabola as best as I can. Okay, so it's not the prettiest sketch, but it does kind of get the point across. There's our parabola. And here at these 2 points, in fact I'll use a different color. Here's one x-intercept, here's the other, and they do happen to cross at a grid line. And so our final answer for our roots are going to be at x equals 1 and at x equals 5. And so we got 2 answers. 2 solutions for this are 1 and 5. If you plug 1 in for x into your original equation up here, it will give you 0. Same thing for 5. If you plug 5 into the original equation, it will also give you 0. So you're going to have 2 answers since there are 2 x-intercepts. Okay, let's go down to example 2 now. Let's find the roots of x squared plus 6x plus 6 equals 0 by graphing the related function. Again, we're going to start with the axis of symmetry. X equals negative b over 2a. B here is 6. A again is 1. And so we're going to have negative 6 over 2, which is negative 3. Now let's go on to the vertex. Again, we're just going to plug in the x value we just found in, and when we do, we're going to get 9 minus 18 plus 6. And when you put all that together, you end up getting negative 3. So our vertex is at negative 3, negative 3. Our a, again, looking at that front term, is 1. And so we're going to start at negative 3, negative 3. We'll plot a point there. And then we're going to go over 1, up 1, since we're standard here. Over 2, up 4. Over 3, up 9. And we can reflect that across our axis of symmetry. And then we'll draw our parabola. So here's the parabola that I drew. And it's not the prettiest thing again, but it does kind of get the point across here. So here, we can't really identify exactly what our roots are because it's some value in between negative 4 and negative 5 and some value between negative 2 and negative 1. So we go back up to the directions and it says, if exact roots cannot be found, state the consecutive integers between which the roots are located. So we have one root between x equals negative 5 and x equals negative 4. And then we also have another root between x equals negative 2 and x equals negative 1. And we don't know what that exact value is. We can narrow it down between those 2 integer values, but we don't know exactly what it is just by looking at the graph. So since we have issues trying to determine it by hand, we move on to other methods. So we're going to approximate zeros on a graphing calculator. It will give us a little bit better answer, a little bit more pinpointed answer than what we get with trying to do it by hand, because by hand we only were able to narrow it down between 2 integers. But the graphing calculator can give it to us in so many decimal places. And so that's what we're going to do. It's still going to be approximation. It won't be an exact answer, but at least it gets us closer to what the actual answer is. So in this next example, I'm providing you some instructions on how to graph a function in a graphing calculator, more specifically a TI-84 plus graphing calculator. And we are going to use this series of procedures here to approximate on a graphing calculator. And it may seem a little weird at first, but once you do it a few times, you get pretty good practice at doing it, and it's not very difficult to do at all. Okay, so let me just run down what the steps are, and then we'll do a couple of examples where we actually do it on a graphing calculator. So say we wanted to find the zeros, or approximate the zeros for 2x squared minus x minus 5, and then we want to round our answers to the nearest thousandth. The first thing you're going to do is enter the function into y equals. So you're going to see on a graphing calculator a y equals key. It will be the top left-hand key right under the screen. You're going to type in there what your function is, and the screen will look very much like this. After you've typed it in and hit enter, then this is what your screen will look like. And feel free to pause this video as you go along with your graphing calculator as you do these steps. Now the next thing you're going to do is go to the calculate menu, and you access it by pressing second trace. So the second key is going to be toward the top left-hand corner, underneath, not directly underneath the screen, but below that. And then the trace button is going to be the fourth button underneath the screen. So you're going to hit second trace, and it'll take you to the calculate screen, and you're going to select item 2, which is 0, because that's what we're looking for. We're trying to find what the zeros are. Third step, select 0, and once you do and hit enter, it will draw the graph for you, and you'll have a little cursor that you'll be able to use your arrow keys to navigate along the curve. Okay? So the next thing you want to do, once it's graphed, take your cursor and move it to the left. Okay, you want to move it to the left of your first x-intercept. And once you do, you're going to hit enter. And it will look very similar to what you see here on the screen. Then in the next step, we'll go back up here to the top to step 5. You're going to use the right arrow key to move the cursor to the right of the intercept. Okay, so it'll end up right of the intercept. Remember, we're talking about left and right. We're moving along the x-axis, but we're moving along the x of this curve, okay? So once you're to the right of it, you're going to hit enter. And then finally, once you've set those two bounds, and they're indicated by these tick marks on the top, you got to do the left one first, then the right one. You cannot do the right one, then the left. It will not work. You will get an error. Once you do the left, then the right, what this does is it narrows down the search area for your calculator, because it takes too much memory to search the entirety of this curve, because it goes on forever, right? So what we're doing is saying we know it's somewhere between this left-hand side and this right-hand side. And so we are telling the calculator to look in that area. And then the last thing you're going to do is move your cursor as close to the x-axis as you can. It may not look this close in some cases, but as long as you get as close as you can, that will do the job, okay? And then you're going to hit enter one last time, and once you do, you will get a value in the bottom left-hand corner of your screen. And that is the value that you can use to approximate one of your zeros. And this one is negative 1.35, and then you've got around the 0 up to 1 because of the 7 behind it. So that's one of them. Then you're going to repeat those steps for your other one. You're going to start on the left side, then you're going to go to the right side, select as close to the axis as you can in the middle, and it'll give you a value for your other x-intercept. And the answers are right there. You've got x is negative 1.351 for the first one that we did, and then 1.851 for the second one. So let's run through at least one example of this on a graphing calculator. And then after we do this one example, I'll leave you to do the other 5, but I will provide the answers for you so you can check what you do on your calculator to make sure that you're doing it correctly. All right, so for this first one, we are going to be looking at this function, f of x equals 7x squared plus 4x minus 10. So I'm going to turn on my graphing calculator. And here we are at our blank home screen. I'm going to hit y equals, because we need to put in what the function is first. So that's going to be 7x squared plus 4x minus 10. And I'm going to hit enter, and that puts in our equation for us. Now I'm going to hit second, trace, to get us to the calc menu. You'll notice calc is there in blue right above the word trace. And I'm going to select item 2 for our 0. And I'm going to hit enter, and it graphs it for us. Now that we have the graph, I'm going to take my left-hand arrow key and I'm going to move it to the left of this graph. Okay, so I'm going to do about here. So I'm going to hit enter. And then I'm going to go to the right-hand side of that x-intercept, and I'll hit enter again. And now I'm going to get as close as I can to the axis and hit enter a third time. And there it gives us our value, negative 1.51. And then we're rounding to the nearest thousandth, so this is a 6, so we've got to round that up to 5. So negative 1.515. Okay, so there's that answer. Now we need to do the same thing for the other one. Well, we don't have to re-enter the equation in. That's already stored in our y equals memory. So all we have to do now is go to second, trace again, to go to our calculate menu. Select the second item, which is your 0, hit enter, and now we're going to start from the left-hand side of our x-intercept. So I'm on the left side of it, hit enter. Then I'm going to go to the right-hand side of it, hit enter, and then get as close as I can. Now you'll notice neither of these look particularly close, so I will just choose one or the other. I'll go with this one, and I'll hit enter again, because that's still good enough to give us an approximation of what 0 is. And in this one, it is 0.943. So there's our answer there. So now that I've gone through the process in real time for you for one of these examples, I'll leave you to practice the others, but I will give you the answers for the others so that you can practice it and see if you get the correct answer. So I'll just read off these answers for you to make sure that you know what I've written here. So the answer to B is x equals negative 0.158, x equals 3.158, C is x equals negative 1.434, and x equals negative 0.232. For D, we have x equals negative 1.940 and 1.340. For E, we have x equals negative 2.347 and 1.597. And for F, we have x equals negative 0.162 and 6.162. So again, I encourage you to go through the process with all of these on your calculator. The more times you do it, the more you become comfortable with it, and the easier it is to do it. You know exactly what to do on your calculator to find it. All right, well, in this section we covered graphing to find the zeros or your solutions for a quadratic equation. But we can actually do a little bit better if we can actually do it algebraically. So in the next section we'll be talking about factoring to find the solutions for quadratic equations.